Here we have a given and a proof statement, and one of the strategies that we like to use is to use the given. So I'm going to look at my given statement where it says that AB is parallel to CD. Here is AB, there is CD, those two are parallel to each other. And then I'll look at this line BC, this yellow line that I highlighted as a transversal. So I've got the two parallel lines and a transversal. It created some angles. Specifically, I'm looking now at angles 2 and 3. The parallel lines form those angles. They are corresponding angles. And I know that parallel implies that corresponding angles are equal. So my statement then is to say that measure of angle 2 is equal to the measure of angle 3. So that's using the first part of this given. The other part of the given says that AD is parallel to BC. So AD parallel to BC, I have markings on those two parallel lines, and then I'll use this line AB, as the transversal. Now focusing on those lines, I see that now I have 1 and 2. They're in between the two parallel lines. They're on alternating sides. So I can identify them as alternate interior angles, and parallel implies alternate interior are equal. Specifically, then my statement would be to say that measure of angle 1 is equal to the measure of angle 2. So I've used both parts of the given. Now I want to go down and look at my proof statement. I want to get angle 1 congruent to angle 3. Connecting these two statements together, 1 equals 2, 2 equals 3, then I can say that measure of angle 1 equals the measure of angle 3, and that is by the transitive property. This is almost identical to what I'm trying to prove. The only difference is I have equal, but I need congruent. So I have one more step where I convert the equal into congruent, and that is the definition of congruent angles. Definition of congruent angles says that if they're equal, then the angles are congruent. If the angles are congruent, then the angles are equal. This is what we were trying to prove, so the proof is over. In this proof we have 3 sets of lines that are parallel to each other. First of all, we have the given. Second step, because L is parallel to M, with K as the transversal, that means we know that angle 1 is equal to angle 2, since parallel implies that corresponding angles are equal. Step number 3, since M is parallel to T, with the transversal of R, then we know that the measure of angle 3 is equal to the measure of angle 4, since parallel implies alternate interior angles are equal. The fourth piece of information in the given is that K is parallel to R. So we have these diagonal lines that are parallel to each other with the transversal of M. And then we can see that angle 2 is equal to angle 3. And the reason for that is because parallel implies alternate exterior are equal. Now we'll look down at the proof statement. We want to get angle 1 equal to angle 4, or 1 equals 2, 2 equals 3, 3 equals 4. So we can conclude that the measure of angle 1 is equal to the measure of angle 4, and that is by a transitive. In this next proof, step 1, reason 1 are both given. And then using the given, since DE is parallel to BC, we have this transversal ray BD. Then we could say that the measure of angle 1 is equal to the measure of angle 3, since parallel implies that corresponding angles are equal. From the other part of the given, we can then say that measure of angle 2 is equal to the measure of angle 3, and that's because of the definition of angle bisector. It's not just bisector, it is the angle bisector. Step number 4, since 1 equals 3 and 3 equals 2, we can then say that the measure of angle 1 is equal to the measure of angle 2, and that is a transitive. And in step number 5, since they're equal, we can convert them into saying angle 1 is congruent to angle 2, and that is because of the definition of congruent angles. In this proof, we have AB parallel to CD. So here is AB parallel to CD, and then we have this line which serves as a transversal. So if we look at that given information, then we know that the measure of angle 3 is equal to the measure of angle 4, and the reason for that is parallel implying corresponding angles are equal to each other. So that's using the first part of the given. The other part of the given says that AE is parallel to CF. We're using that same transversal again. This time the angles that are equal are this angle and this angle. Those are the two angles formed by the parallel lines and the transversal. So I could say that the measure of angle EAC is equal to the measure of angle FC. And I don't have a letter down here, but I know that there are a lot of points that are on this line, so I'm just going to put a point there. I'll call it point G. So that means that this is angle FCG. That's also because parallel implies corresponding angles equal. That's still in step number 2. In step number 3, now I want to look at my proof statement. I want to get angle 1 equal to angle 2, and those haven't been introduced into the proof yet. However, if we look at the drawings, specifically up here at the top, I see that angle 1 and 3 together form angle EAC. So what we can say then is that the measure of angle 1 plus the measure of angle 3 is equal to the measure of angle EAC. The reason for that is the angle addition postulate. And likewise at the bottom, I'm going to get angle 2 into the proof. And I see the angles 2 and 4 together make up angle FCG. So we'll say that the measure of angle 2 plus the measure of angle 4 is equal to the measure of angle FCG. So now the important pieces have been brought into the proof, and we're going to do some connecting here. Angle 1 plus angle 3 is equal to angle EAC. EAC was equal to FCG. FCG is equal to 2 plus 4. So we're not modifying any expressions or any binomials. We're keeping them the same. 1 plus 3 equals EAC, which equals FCG, which equals 2 plus 4. So we can say the measure of angle 1 plus the measure of angle 3 is equal to the measure of angle 2 plus the measure of angle 4, and that is transitive. So we're one step closer to getting measure of angle 1 equal to measure of angle 2. And in fact, if I look on the left side of the equation, there's angle 1. On the right, there's angle 2. However, there's an angle 3 on the left and an angle 4 on the right. If I look back up at step number 2, we had this before. We haven't really used that yet. But if I use this green equation and subtract it from our last one, the angle 3's would eliminate each other. The angle 4's would eliminate each other. So then we'd be left with measure of angle 1 equals the measure of angle 2, and that reason is subtraction of steps 4 and 2. That's what we're trying to prove, so that proof is over.